Der er meget debat om den arktiske havis, og om hvorvidt den smelter hurtigere end tidligere. Her taler jeg med Dr. Ronan Connelly om hans studie fra 2017, som kigger på de data, man har til rådighed til at estimere forholdene i Arktis. Om udbredelsen af havisen er så meget anderledes end tidligere. Velkommen indenfor.
Yeah. Moving on to the next paper, you also wrote about the Arctic ice trending from you compared the satellite era with the long-term trend, and it's a big topic about Arctic Sea, like it retreating and how much is it retreating compared to history data. Can you talk about a little bit about that?
Yeah. So. You're probably referring to this, a paper 2017 published in Hydrological Sciences Journal. And so what we did there, again, we were looking at the UN IPCC report and a lot of the papers in the field at the time. Most of the literature was focusing on the satellite era estimates of Arctic sea ice. And some were looking at the Antarctic sea ice, except that the Antarctic sea ice trends were not fitting with the narrative. And so most people were, because it was, if anything, slightly increasing over the satellite era. So most of the focus is on the Arctic. And the models, because you hear people saying, oh, this can be explained. It can be explained after the fact. You can come up with post hoc explanations for it, but the models don't explain why it should be decreasing in the Antarctic. So that's another topic. But we were more concerned about the arbitrariness of the starting of the satellite era, because we had been in our previous work we had been looking at Arctic temperature trends. And what we were finding is that in the Arctic temperature trends, the data is limited, but there's a very strong signal that comes out of pretty much all of the Arctic temperature records that shows a warming starting in 1900 or the end of the 19th century is probably the earliest we can go with the temperature records. The temperatures were kind of increasing in the early 20th century up to the 1940s. Then they were decreasing from the 1940s to the 1970s. And then they've been increasing since the 1970s to present. The satellite era, the estimates of Arctic sea ice, begins in 1978. That's the first one. So they begin just after more than 30 years of Arctic cooling, and they just happen to be coming in on the dip. And so the Arctic cooling for 30 years and then the dip, and then it starts to increase. And so, yes, Arctic sea ice has been generally decreasing since the 1970s, and particularly since 1978. But if the satellites had been launched in the 1940s, and we had going back then, we would expect that you would have Arctic sea ice increasing and then decreasing. But the problem is, how much would that be? So that was the key bit. We were like, what can we do about the pre-satellite era, because that is essential for the context of describing these recent trends. There's no point, if you were to take any stock market property and you were to look at either at a bit when it's starting and to predict, oh, this is increasing, it'll keep increasing, then you at some point you're gonna be wrong. If you look at it and you say, oh, it's decreasing, then it's increasing, then you can kind of say, okay, well, maybe it's increasing and you can start, but you're coming from a better position there. So we tried to look at the pre-satellite era, and it turns out that there had been some work in the 80s and 90s and 2000s, and it was ongoing when we started at it, of looking at ground-based and different estimates of sea ice coverage beforehand. So, for instance, you had like aerial reconnaissance, or you had in the early 20th century, you had Arctic ships that were they were exploring or doing transport, and they were able to noting the ice edge. Or you had like stations that were Arctic monitoring stations that were looking at ebbs and flows of the ice. And so some people had taken some of those estimates, and then they had stuck them together. And this was John Walsh was one of the main guys. Walsh and Chapman did the main analysis. And while we criticize the analysis itself, I have to say that we used a lot of their data for our analysis. It's just we looked at it in a bit more detail. So while I might be criticizing their analysis, they did do a lot of work in gathering information. So, you know, the problem is, though, what we found was, okay, one of the main data sets they used was actually, yeah, interestingly, it's the Danish Meteorological Institute, DMI. They obviously, with connections in Greenland and things like that, like this, you have been monitoring, have a lot of records of the Arctic sea ice. And so the DMI had been publishing these monthly maps showing the Arctic sea ice coverage for a given month. And so what Walsh and Chapman had done is they'd taken those maps and they had digitized, tried to work out the area of ice for a given month. And then they added them onto the satellite era. The estimates that are taken from the satellite from above versus these maps that the DMI were keeping. And what we noticed is, well, a couple of problems, but just to illustrate it, we show, in the paper, we show two maps of the same month. One is by the DMI in the 1950s, from just an arbitrary month. The other is from the Russians, from monitoring, from their aerial reconnaissance. So this was during the Cold War. There was almost no communication between Europe, the US, and the Soviet Union. So they were keeping secrets from each other. So the DMI had done these lovely maps where they put in little bits of red all around the regions where they had measurements. They put in, we know this is ice free, this has ice, and they put them in the region, particularly around the North Atlantic, very well defined for each month. And then for all along Siberia and quite a bit of the Canadian bit as Arctic as well, they just would say ice supposed, and they just put it in blank. And so for all across Russia, it was supposed that it was ice filled for pretty much the entire Cold War until the satellite era. And then miraculously, we see this dynamic ebbing and flowing of the ice along the Russian Arctic. Now, the Russians, meanwhile, they didn't have access to the DMI stuff, but they did have access to their coastline, and so they were monitoring it. So in the paper we show Russian observations for that month and the DMI's estimates for the things, and you can see the DMI's estimate was just ice filled for the whole Russian Arctic, and whereas the Russians were seeing huge ice-free regions. So what we realized is when you're combining each of these data sources for the past, they're not apples with apples. It's apples with oranges. So the satellite era is probably the most reliable bit. And so you can't just take those maps and use them and then stop using them and then just use the satellite thing. Change from one source to the other. Cold. So what we did is we took each of these earlier sources and we divided them up into regions and seasons. Into the 3 regions we deal with: the Siberian, European, and the North American Arctic regions. And we divided them into the spring, summer, autumn and winter seasons. And then we took the estimates, and then we took from a given data source, we used Arctic temperature estimates that we calibrated against the satellite era to try and recalibrate each of those earlier sources to be comparable. And it's a little bit messy and a little bit crude, but and so the error bars were quite large, but what we showed is this period, and you can look at, we do it for all of the different seasons and for each of the regions, but the overall one, particularly say comparing it with the summer, you can see this dynamic Arctic sea ice growing in the early 20th century up to the 40s, then declining to the 70s, and then other way around. I'm talking the temperatures. Arctic sea ice declining from the early 20th century to the mid 40s, then increasing to the late 70s, and then decreasing since. And so you show this dynamic going back. There's been some, that's it. So this is an estimate going back to 1900.
And there's a kind of a logic that it follows, somewhat follows the global temperature. When it get a little bit warmer, then the sea ice retreat, and when it get a little bit colder, then the sea ice will grow. Like it kind of makes sense.
Yeah, I would say it's even more so if you focus in on specifically the Arctic region, which is kind of broadly tracks the global temperatures, but has some extra features in it. So that's why we focused on the Arctic temperature regions for each of the regions as well. Yeah.
It's even the global temperature is changing. There's a lot of like regional differences, and you have to take that into account, I guess.
Yeah, well, I just as a comment, that there is actually arguably there is no global temperature. What people are usually referring to is so let's take the land surface air mean temperature. Globally average land surface air temperature. This is something we've written a couple of papers on looking at, because this is the main estimate that people have been using since the 80s. More recently, like in the late 80s, early 90s, people started looking at sea surface temperatures, marine air temperatures. Most of the discussion since the 80s, and it's still the main metric people are doing, is looking at the average temperature measured in a few thousand weather stations around the world. So your typical Stevenson screen, like you can get these weather. They're kind of quirky looking boxes. The Stephenson screen. It was actually interestingly invented by the father of Robert Louis Stevenson, who wrote Treasure Island, if people are interested. But Stevenson developed a particular latted housing unit that you could put a thermometer in, and you could start recording it. So it became very popular, trying to be representative of the air surrounding it. So typically about the thermometer is about 2 meters above the air, and it's in this box. And in this box is in a weather station. And people reporting the temperatures, they might issue the monthly average of these temperatures, and that then gets archived. And so starting in early 20th century, but major interest in the 80s. In the 80s there was, I think, 3 main groups started looking at taking these temperature records, past temperature records from these weather stations, and then taking each one and looking at the long-term trend for that station of the annual 2 meter height temperature, and then averaging it with all of the stations all around the world that they can get. And then they said that is the global mean surface air temperature. Little bit like you might have like in the stock market, where you'd have like the Dow Jones or the S&P or any of these indexes, where you combine all of the each company in the top 500 is going up and down, and then you look at the average of all 500 or 1,000 or whatever, and that's what is typically called the global mean surface air temperature, or different variation like that. And that has generally increased since the late 19th century, and that's what people typically mean, whether they know it or not, when they say global warming.
And it was after a very cold period with the little ice age, so it's kind of expectable that the global temperature will rise from that.
Yes, this is another point, because what people will use what are called paleoclimate estimates. So this is another controversy, where our complex problem. Again, the fewer the facts, the stronger the opinion. So people in paleoclimate is trying, because people weren't recording temperature measurements in the 1500s, because the Celsius scale or the Fahrenheit scale, Celsius was, I think, 1750s by Anders Celsius, and there'd been another unit before, the Remor or something. There's a couple of different. So they didn't come up with the idea of thermometers and doing it until a few centuries ago, and it only started becoming systematic in Europe and the US, or in North America, say the 18th century, and then very little worldwide. So it's only really as we get towards the 19th century, the end of the 19th century, even the 1950s and 60s, there's actually a huge increase in the amount of data of weather stations globally available since the 1958 was what's called the 1957 to 58 was the International Geophysical Year. And so a lot of scientists said we really need to start monitoring the planet better. And so international agreements to try and encourage measurements around the world. So there's a huge increase in weather stations. Also, that was the start of the space age. And we mentioned about the satellite era. The satellite era arguably began in 1958. But the Arctic sea ice, the sea ice estimates were 1978. That was the systematic, continuous record against 1978. The early things were just proof and concept. We could, in the 1950s, we hadn't gotten into space. And the idea of putting a box orbiting the planet was amazing. It is still amazing.
Yeah. At that time, it was kind of fiction, like something you see in the movies. Dr. Ronan Connelly, I will thank you for doing this. I appreciate it.
Thank you for inviting me.